Hello guys and welcome back. So now we're going to start playing with the Pyro Solver and see how it works. And the first thing that we need is I'm going to copy these guys. I'm going to copy the dot network and let's call this Pyro. Let me drag it here. Oh cool, it's already changed, and let's view this node. And then the next thing that we need, actually let's set up the network. So I'm going to delete all these guys except the gas resize and the smoke object, and let's create a Pyro solver. Let's connect this here, let's connect this here, and we need the sourcing now. So let's create a source volume, but we don't have any valid source for this. And what this solver requires for the input to have, it requires a fuel field, and based on that fuel it will decide how much heat, burn, and temperature it's going to generate. And these are all fields inside the Pyro solver. So let's create a source fluid source, and here under the container we need to change it to source fuel. And now if we go back, you can see it changed the name here to fuel. Temperature, this is a temperature field as usual, and then there's a valve field. For now I'm gonna ignore the velocity. I'm just gonna create a fuel and temperature, and I'm going to scatter some points here and use these to create the volume, to create the fluid source. So let's use this, and let me increase the voxel resolution so it's faster to generate. And then under the method we need to change this to stamp points. You can see now it's working. Let's increase the number of points, and let's increase the stamp points distance to 0.8 to capture all the points. Cool, so now we have a source. Right now the source has some noise and it's animated over time. I don't want the animation, but I don't want to override it as well. So I'm going to put down a time shift and lock the frame to be 1 so it doesn't recompute the node every time. And if I middle click, you can see we have fuel and temperature. Okay, and let's create a null, and we're just going to try and understand the solver here. We're not going to be aiming at creating any high-res sims or any high-quality sims at all. So let's create out fuel, and let's move these guys over. Let's give this guy a red color, and here let's change it to out fuel. Cool, so I'm not gonna change anything except, let's leave it at that. So I'm not gonna change anything, I'm just gonna hit play, and it snapped. The reason for that is, what's the reason for this? We need to change this to source fuel. The default is source smoke, and we have to make sure that we change that. So let's hit play, now it's working. And you can see we're getting expansion, and hopefully it's gonna rise up a bit. Yeah, it's going up, but currently the display is not giving us what we want. Okay, and we're not seeing anything except the density right now. It's not even lit. And let's middle click at the smoke, the Pyro solver. You can see it has a temperature field, density, burn, divergence, pressure, heat, fuel, velocity, and resize bound. So the temperature we're used to, density we know, divergence we know, pressure we know, and these are the new guys. So there's a burn, heat, fuel. The fuel is coming from this source, so that's coming from our input. And let's actually visualize. So there is these settings here to decide which channel to view. I'm gonna untick density, and let's go one by one. Let's take a look at the temperature. Okay, this is what the temperature looks like. Let's take a look at the fuel, and this should match exactly the sourcing that we have, which it does. And then we have a divergence. We don't need to look at that. And then we have a burn field, and then we have a heat field. Cool. So where are these channels coming from? We didn't have them before. It was just temperature, and then divergence, temperature, divergence, density, and pressure. Those are the default one. And these are actually coming from the Pyro solver. This is part of the combustion model. And I'm going to start playing with these values, or go over them, at least these set of controls, to explain how they work. And under the multi-field, I'm going to untick density. I'm going to tick on multi-field and go here. And I want to create a visualizer that shows me the density and the temperature. So I'm going to use the smoke is going to be the density. And then under emission, I'm going to type in temperature for both, for the scalar value to drive where the temperature is, as well as the color field. I'm going to set this to 1. And let's just change this color to have a slightly more red. Okay, so let's go back, hit play. Cool. So let's understand how this works. This guy is sourcing the fuel. This is the multiplier for that. So let's increase it to 10. Okay, we can see there is more expansion happening. Cool. So let's set this back to 1. Let's hit play. It's expanding slowly, and then hopefully it will rise at some point. And then we also have a temperature, so we can increase this to make the initial incoming data hotter overall, which will be used which will add to the new temperature that is being generated. So we'll leave that at 10. And then I will also want to have more fuel coming, so I'll set this to 6, and you can see it's expanding already. Actually, let's set this back to 1. And I'm gonna start playing with these settings. Now let me change the resolution to something lower so it's faster. And I'm going to, let's hit play. I want a better visualizer. You can see right now it's everything is red, is white, and I want better remapping for these fields. So I'm gonna take this guy, I'm gonna copy it. I'm gonna take this, copy it, and then paste it here so they're both linked. And let's set this to 5, 10. Cool. So now it's using the range better. Let's try 30. Yeah, something like that. Cool. So you can see it's working. Now there is a clipping issue, and the reason for that is because of this. And there is this subtract here, which basically takes whatever field we're telling it to resize. In this case, it's the density, and it's subtracting this much from it and using that. So I want to lower this to 0.01 so it doesn't subtract too much from the density field, and that will give it more room to expand. And let's actually increase the padding, which should give it a bit more room. Yeah, cool. So it's working. Now let's take a look at these settings. The first one is the ignition temperature. And let me set this to something higher. And for some reason, it flashes for 1 frame and then dies. And the reason for that, what this does is, based on the temperature of the incoming source, it decides whether it's gonna burn it or not. And right now we're setting it to 10, which is basically exactly equal to the value that we have here. Actually, if we set this back to 1, it's not gonna flash at all. And this threshold is not being met. We don't have any temperature that is equal or higher than this value. But if we multiply this by 100 and hit play again, it's going to meet that threshold, and it's going to start emitting smoke and reacting. So that's what the ignition temperature is. Anything that is below that meets that temperature is going to be used in the system to create heat and burn. Now I'm not so sure what the heat and burn are, where are they coming from, but it's a loop between the fuel, the heat, and the burn that generates temperature and new density in the end. And right now we have fuel coming in, and this burn rate decides how much fuel is going to be burned. And it was set to 0.9, which is 90% of whatever fuel we inject in the system. And I'm going to set that to 0. You can see nothing happens because nothing is burning. Let's set it to 0.2. And it's going to burn only 20% of the incoming fuel. Let's reduce it. It's too low. So let's set this back to 0.5. I'm going to lower the temperature because it's too high. I'm going to set it to 10. Let's hit play. Cool. So this is going to burn 50% of the incoming fuel only. We can set it to 100%. And now it's burning everything. And you can see it's expanding more as well and generating more smoke, because this all the system is related one to another. It's a loop that everything is affected by whatever happens in these steps. So fuel efficiency, there's also randomization, a chance that is added on top, whether the fuel to have some fuel not getting burned. In a flame, for example, that like I showed in the first video, the fuel efficiency should be 100%. We shouldn't get any fuel. If it comes in, if it gets near a hot area, it's gonna burn. It's gonna be converted into a flame, and this is basically where we can control that. And I would recommend, for example, if you're gonna create a fire and or flame, to set this fuel efficiency to something high. It doesn't have to be 1. And you can see now everything is burning. And I'm gonna try and restore each of these settings after I explain it, so that we only change one value. Now, after the fuel gets burned and it generates heat, it also generates temperature, which is what is causing it to rise up. Apart from the source that were important, that there's also a new temperature being generated by the fuel ignition, and that result we can multiply. So here I'm setting it to 10, and that will multiply the temperature. It's not going to multiply the amount of temperature, it's going to multiply the value, the intensity. So it's going to rise higher because it's stronger. And we can set it to 0, and it's not going to go up as much. It's only going to go up because of the incoming data. So let's set that back to 0.05. And then we have the gas released, which is a very important part of the system. So I'm going to set that to 150. You can see how much expansion is happening. And based on the images that we saw, we have a very fast ignition, very fast expansion in the first few frames. And what I'm going to do to emulate what an explosion looks like, I'm going to animate that over 5 frames and set it back to 0. So 500 in the first frame, and then it goes back to 0. Let's actually move this a bit, maybe give it more frames, and let's set it back to 15, not to 0. And that should have it expand in the beginning, and then goes back to the normal value, which will create a much faster expansion. And this is basically the main driver for the explosion. Now we can use all the other ones as well to cause the sim to expand, which is the primary criteria of an explosion. And let's see, let me take a look at something super quick. We can also combine this gas released with the fuel sourcing, so we don't have to have the fuel be the same value across the board. We can change it. So let's say I'm going to set it to 12 in the first frame, and then I'm going to turn it off to, let me see, I'm going to turn it off to 0 at frame 6. I'm also going to do the same thing for the temperature, and let's set this back to 10. We may have to change this because it's going to expand too much. Yeah, you can see how fast it's expanding a lot. Actually, let's wait and see what's going to happen. And then all of this should also go up at some point. But right now the temperature is not too high that is being generated. So maybe let's increase the temperature output here. Let's multiply that. And you can see it's expanding. Unfortunately, it's uniform. I mean, that's what the system is giving us. That's what the reaction of all these fields is given us, and then this smoke will eventually go up slowly. So this is the primary criteria of an explosion, is the expansion, and we have that. We can control that through the system. But if you look at the all these values, there is a lot of inputs. There is a lot of things that we have to tweak, and it's driven from here, it's driven from here. There's also more controls in these guys, especially this guy, which we're going to take a look at in a second. And it's just too much values to tweak, and this is something that we have to be very careful about. Even when we design a tool, I see a lot of stuff that where, for example, you get a bridge or something that builds a bridge, and you have 100 controls. You don't need that. You have to think efficiently as to what type of bridge you're going to create with the system, and try to make smaller module that can hit the artistic goals of the specific topics that you have, instead of building a super giant system that has everything. Now, I fully understand why Side Effects did this, and I think it's not too much control, but we can make something much more efficient. And the main thing that we're going to do in our solver is have a primary control that can control the expansion. Okay, and this system is a little bit backward because you can generate expansion without having temperature, which is not correct, which is not necessarily the case. We want to be able to expand and then decide where the temperature should be, where the fire should be in our system. And to be honest, all these controls feels a little bit, they're not so friendly. You have to spend a lot of time. And then you're not going to be able to control the expansion to look the shape that you want. We're not going to be able to create this expansion here like that because of the limitation of all these controls. We don't have a lot of control into the expansion itself, and we want to create a system that can allow us to do that. Okay, so the last one I wanted to talk about is, okay, I will talk about these three guys, and then maybe later we'll continue the next ones. So the flame height is basically how soon the flame decays, and the higher this value, the shorter the flame it's going to be. This value is not in unit or anything. It's just how fast the flames decay. And then this smoke is when the heat field decays and it reaches this threshold, this cutoff, it gets converted into a smoke and starts emitting smoke. And for example, when you have, let's say, a tire burning, for example, you would want to tick this on because it will create a denser smoke. You can also say if the heat is 0.5, I want to convert that into a black smoke, and you can also control the amount. So let me change all these guys. I'm going to lower this to 100, and let's hit play. And you can see now it's much denser. We don't see the field anymore because of the amount of smoke that is being emitted in the system. So let's set this back to 1. Actually, let's set this back to 0.1 so we don't cut off the heat field very soon. And the higher the value, the more smoke you're going to emit. And then there is this guy here. We'll continue these in the next video or later when we build a better understanding of this. This guy is when we import the fuel field. Right now it's just being sourced and it's not being affected by the system. I believe it's very important to advect that field with the system. For me personally, it should be affected 100%, but most of the cases I've seen, it doesn't work. If we advect it, 100% changes the result completely. So we're going to set it to 0.05, and this can have a drastic effect into the visual of the result. So let me do something super quick. Let me increase the cache here to 30, and let's go back. I want to cache more frames and take a look at this in the DOP context with some lights on it. Let's view this guy. And in the next video, we're going to tweak this to make it behave in a more natural way after we understood how these settings work. Okay, so what I'm going to do is, let's hit play. Cool, so we have fast expansion. It's too much. It's causing those rings to appear. And then I want to visualize the temperature field. So I'm going to create a visualize node. I'm going to do the same thing that we did in DOPS. So under here, I'm going to use temperature, same temperature. Take these two guys, copy this, paste it here, and then under preset, we're going to change it to black body, and let's improve the ramp to look more like fire. Okay. And let's set this to 1. Cool. So you can see we have a lot more fire happening in the system. And we can also tweak the buoyancy to cause all of this to go up a lot higher, which will completely change the sim as well. Cool. So we'll continue tweaking in the next video. Thank you for watching, and see you in a bit.